in here a bunch of different, oh my goodness, you're gonna film portrait?
Yes.
No way you're gonna film portrait. All right, so, hi. So what we're gonna do is this. I have a bunch of tuning forks with frequencies already listed on them. All right, they actually have a letter too, which is the note. Okay, so it has a note and the frequency. All right, with these, what you're gonna do is you're gonna write down the frequency on the chart. Okay, so I'd look at frequency of fork, I see 261, I'd write that down, 261.6, whatever it is. All right, then I'm gonna hit it here, and I wanna keep the tuning fork just above it. Okay, the biggest people, some students will have trouble just because they don't hear it. Keep that really close and just go fast at first. Right there, see that? Nice and loud, wherever you hear that hoot. Again. Okay? Now, whatever that length is, I want to measure the length from the top of this pipe to the water. Okay, so the meter stick will just barely touch the water. Alright? I get 29.5 centimeters. Everything you measure has to be in meters. You have to put everything in meters, okay? So my length there would be 0.295. All right, you're doing your own lab. Don't do mine for me. All right, 0.295 meters. All right, I had a frequency of 261.6. Now, the wavelength, I have a formula. It's right here. Okay, see the formula? Right there. Because that was a general basic formula, however, the diameter of the tube does kind of affect it. All right, so for this lab to get better numbers, I'm using a better formula for it, okay? If I were to assess you on a test, you just think about quarter lengths and all that stuff, but we're gonna do this for better numbers. You need to measure the diameter of the tube. All right, when you measure the diameter of the tube, all right, again, put that in meters. Once you measure that, just write D equals to the side, and that's what you'll use as a lowercase d right here every time. Okay, it'll be about 3 centimeters or 0.03, somewhere around there. You'll calculate that. All right? So, you measured the length of the tube, right, to the water. You have the length that you put down here. You plug that into a formula and you get the wavelength. We know from our formula, the first slide of waves, V equals F times lambda. So frequency times wavelength will get you the velocity of sound. Okay, because V equals F times lambda, so F times lambda, frequency times wavelength, will get you the velocity. Alright, so you're going to do that 3 times with 3 different tuning forks. Just take one at a time. Okay, and then I have a different section. My other section will be using the tuning fork of mystery. It's mysterious because there's tape over the fork. Works for you? Good. All right. And you can almost not see it. So, for this tuning fork, which is the bottom, and this tuning fork only, you'll do the same steps. You'll measure, find your hoot, measure that length of the water just like before, plug it in the formula just like before, and get a wavelength. But instead of multiplying times the frequency, because there's tape over it, you don't know it, you're going to work your way backwards and solve for this frequency. And for this section, and this section only, you're going to say that the velocity is dependent on the temperature of air. Okay? So you will use for the bottom part, the mystery fork only, you'll use the formula I said before, 331 plus 0.6 times T. I'll give you the temperature of air in a second. Okay, so I'll give you, it's in your notes, 331 plus 0.6 times T. So then, for the last part, for the mystery fork, or the tuning fork of mystery, okay, this is your V, okay? Your wavelength is the way you did it before by measuring the length of the tube in the water and getting a diameter and getting a lambda, and you're going to solve for F in this case. Okay? Once you get it, let me know what number you get and I'll let you know how you did. Okay? That's how you do the lab, and I'll give you the temperature of air in a minute. Thank you. First one is this. Never, ever, ever hitting tuning fork against something hard like the table. I do not want to hear any of that noise, okay? If I hear that noise, I'm going to cringe. It's also bending my tuning fork, so you don't hit against anything hard. The only thing I want you to hit against is this piece of plastic. Frankly, that's probably even a little too hard too, but I'm okay with it. So just lightly hit against there. Do not hit a table. Do not hit anything else, okay? Just this part right here. All right? The other part is this. Don't ever put a tuning fork to your ear, because you'll go deaf. All right? Or it's going to just severely damage your eardrums. So don't do this. Sound good? Okay.
Katie's already done.
Actually,
You're a little
let's not
late.
try it.
No, let's not try it. All right, that's it.